In this video, I'll be explaining about the bipolar junction transistor or BJT, which is a fundamental semiconductor device used in electronic circuits for amplification and switching. BJTs are crucial components in modern electronics due to their ability to control large currents using small input signals. The objective of this experiment, Practical Work 3, is to investigate the BJT terminals, BJT types, and the material used in BJTs. BJT terminals and functions. A BJT has three terminals. For base, this is the control terminal. A small current at the base controls a larger current between the collector and emitter. For collector, this terminal collects carriers from the base. It is connected to the positive voltage for NPN and negative for PNP. For emitter, this terminal emits carriers into the base region. It is usually connected to ground in NPN or positive voltage in PNP. So the diagram here to show current flow. So at the left side is NPN transistor. Current flows from collector to emitter when a small current is applied to the base. And the right side is PNP transistor. The current flow is reversed. It flows from emitter to collector when the base is at a lower potential. There are two main types of BJTs. NPN transistor. The majority carriers are electrons. Current flows from collector to emitter and it turns on when the base is positive. And PNP transistor, the majority carriers are holes. Current flows from emitter to collector and it turns on when the base is negative relative to the emitter. So, to identify them, you can use a multimeter. For NPN, base to emitter and base to collector show forward bias diode test. For PNP, emitter to base and collector to base show forward bias. Biasing condition also differ. NPN requires base to emitter junction to be forward bias and collector to base junction reverse bias. PNP needs opposite polarities. So I use 2N222 transistor. Okay, for the right side leg, it is first terminal, and in the middle leg is terminal 2, and the left leg is terminal 3. Okay, firstly I use terminal 1 and terminal 2. The result shows that terminal 1 and terminal 2 gets infinity ohm. Okay, then I change from terminal 1 to 2. I change it to terminal 1 to terminal 3. After do that, then I get the result is the same like the first experiment. It also get infinity ohm. Then I put red probe on the terminal 2 and the black probe on the terminal 1. Then the result show that I get 75 ohm. Okay, so after I get the result, I change the black probe on the terminal 3, but the red probe is on the same terminal, that is terminal 2. The result that I also get the same that is shown in the multimeter, that is 75 ohm. Okay, then I do the red probe into the terminal 1 and the black probe is on the same leg, that is terminal 3. The result that show in the multimeter is the same like the first experiment that I do. It also get infinity ohm. And the last experiment that I do, I change the red probe into the terminal 2 and to the terminal 2, and the black probe is at the same leg that is terminal 3. The result will show to you that it is get 75 ohm like the experiment that I do for the experiment 3 and experiment 4. Okay, so now I will explain about BJT materials. BJTs are commonly made from two semiconductor materials, silicon or Si, germanium or Ge. Silicon is more widely used due to its greater terminal stability, higher operating temperature, better electrical characteristic. Germanium has a lower threshold voltage but is more sensitive to temperature, making silicon the better choice for most applications. Okay, so now for the conclusion. To summarize, we explore the structure and function of BJTs, including the base, collector, and emitter. We also examine NPN and PNP types and learn how to distinguish them. Lastly, we discuss materials used in making BJTs and why silicon is preferred in modern electronics. Understanding BJTs is crucial in designing and analyzing electronic circuits. It helps in choosing the right components and ensuring proper circuit functionality. Thank you for watching, and I hope this explanation helps you understand BJTs better. Sorry for my bad explanation. Hope you will be great in your future.